If I'm honest about it, initially Akka was not easy. It didn't make my life easy at first. It was a new paradigm. It was a new way of thinking about programming. And it wasn't something that I initially grasped right away. But the good news is, once I really started to dig into the actor model and truly get an understanding about what it meant to model the world around you, to model state, to model message passing, to model resilience and elasticity, that's when it actually clicked to me that, this really fits and this really helps me to solve the problems that I have at hand. It allowed me to make progress on problems that, using other paradigms, I probably wouldn't have made the same progress on. And so that's really how Akka just helped me a lot. One of the reasons I think that Akka is a perfect match for cloud applications is because cloud by nature assumes distribution. And Akka is a programming model that also is built for distribution out of the box. It's not something that's bolted on the end. It's not a model. The actor model itself is not something where you've kind of fit in how to distribute it. No, that's truly how it is. It is modeled after the world, after objects, after things, after people, after networks. I mean, this is something that truly fits with distributed people in general, distributed systems in general, distributed objects and things and IoT. I mean, that's what it is at its core. And so when you think about that, you think about cloud native and distribution, you have to think about things like state and having distributed state. And so this idea that you separate your logic, your entity's state from the state itself, such as, what we've done in traditional architectures where you've got a 3-tier architecture. And the idea of distributed is, hey, let's make a stateless application and put state somewhere else separate from the application. And also let's distribute that and distribute the statelessness on top of it somewhere. I mean, you get a real mismatch. You don't really solve the problems that you need to solve with distribution by doing it that way. You need to be close to your state. Your entities and the state of your entities need to be close to each other, because what knows more about its state than the entity itself, the things that have taken commands or events or have actions? I can tell you more about myself than other people can tell you about me. So whether I keep a journal or something, hey, this is my journal that I've written in, and someone else can go and take this journal and maybe try to distribute it or copy it all over the place. But the quickest way to get the answer and the best interpretation for what's going on with me is to ask me myself. And that's what actors allow you to do. Your actors allow you to ask and know and control the state of your entities within themselves. And it doesn't make you depend on, state that can lie inside of a distributed data store somewhere else. So I just think this idea of having a distributed system that takes distributed state as a first-class citizen, not as something to be dealt with, but as something that is core to the problem you're solving. I think that is the future, that is the world, and that is what makes a system or a paradigm or a programming language or a toolkit cloud native. And that is why I find Akka as a perfect match for cloud native. I think other people are going to go the same way. I think that it's the future. I think that you're going to find more people understand that maintaining distributed state is one of the best ways to solve some of the problems of the distributed world that we live in.